All right, so this one, yeah, it's an equation x minus 2. That's the square root of x minus 2 equals 6. And so just like we've seen on those last ones, I'm going to take the left side, the entire left side, and square it. And then the entire right side and square it as well. And what does this do? It takes whatever's on the inside of that root and just kind of brings it down for us, which is pretty nice. Then yeah, right here we got 6 times 6, which is 36. So x minus 2 needs to equal 36. Remember, this x minus 2, it's kind of like our absolute value equations, not that I think anyone really remembers or wants to remember that crap. But we're looking at the inside of that square root, right? If I can make the inside of the square root 36, then I should get a true statement, right? So at this point, applying principles of equality, I would say let's go ahead and add 2 to both sides. Here I'll drop my x, add zeros out, equals 36 plus 2 is 38. Okay? Now that should make the original equation a true statement, which was square root of x minus 2 should equal 6. This time I'll make sure to put the question mark over there, but the x, I'm replacing that with the 38 that we found. And then just solving this here, 38 minus 2 is 36. Remember, we've seen that before. And does that equal 6? Sure does. 6 does equal 6. That's true. And so I can say, well, x equals 38 is definitely the solution to our original equation. It's the value of x that makes it true. And just to go back, as of right now, for this type of equation, this is the only value of x that would make the equation true. Any other value that you replace x with would make it a false statement. Okay, remember, the equal signs are comparing one side or one expression to another. This is, I don't know that we really hit too big on this rule here, but the rule is if you have the, I guess, again, it's the square root of one side, again, maybe it's equal to something. It could be square rooted, but it doesn't have to be. If you square both sides here, all that's going to happen is whatever's on the inside of that square root right there is just going to be itself. And then on the other side, of course, you have b squared, but whatever that is. But we're saying that we know that the two values are equal. Again, it's a right here. Yeah, it could be, right now, like that, this problem, we're looking at a binomial. It could be a trinomial. It could be just a complete polynomial. It could be ugly as crap, okay? And you will see sometimes that they'll make some of those square roots look pretty ugly, but for now, we're just kind of starting out with this kind of stuff. So yeah, be careful. This kind of goes back to what we've seen before with the polynomial stuff as well. It's like x minus 2, if you were to square this is not the same as x squared minus 2 squared. See what I'm saying? Because you have to square the entire binomial. And so this one, I mean, if that helps, yeah, put that in parentheses so you can see that it's the square root of all this stuff, and then you're squaring that. Again, this square, I hate to say cancels out because it's going to be a phantom 1. We just haven't really gone into it in too much detail. It's going to make a phantom 1 out of this square root.